Here's how to find the square root of a number without using a calculator. First, take a look at square root of 65. If we take that number, put it in the calculator, you get 8.0623, of course, round it off to the 4 decimal places. First thing we want to do is find the number that's a perfect square that's closest to 65. And that's going to be 64, which is 8 squared. So, to find the square root of 65 without a calculator, we're going to start by saying 8 plus, and on the top, or the numerator of the fraction, what we want to do is take the 65, subtract 64, and we get 1. So we'll put the difference on the top. In the denominator, or the bottom of the fraction, what we want to do is put a 2, and that's what we call a constant, meaning it's always going to be 2, regardless of the number that we're taking the square root of, times the number that's right here, or 8 in this case. And if you go ahead and add 8 plus 1 over 16 and change it into a decimal, we get 8.0625. Notice, 8.0625 compared to 8.0623, the difference is not that big, meaning using this method, we're still able to get a number that's pretty close to the actual square root. Let's try the same method on a bigger number. If you input square root of 150 in the calculator, you'll get 12.247, rounded off to 3 decimal places. Then again, we need a perfect square that's closest to 150, and 144 is the closest perfect square to 150, which is 12 squared. Then, to find the square root of 150 without a calculator, we're going to go 12 plus 150 minus 144, which is 6 in the numerator, and 2 times 12 in the denominator. Again, the 2 is the constant, or it's always going to be 2, and the 12 is from here. If you take that 12 plus 6 over 24 and change it into a decimal, you'll get 12.25. Again, notice the difference. We have 12.247, which is 12.25 if you round off to 2 decimal places, and the estimation method that we use is 12.25, which is pretty darn close. And here, let me show you an example where you have to change the method just a little bit. Let's take a look at square root of 97. If you put that in the calculator, you'll get 9.8488, again, rounded off to 4 decimal places. In the other 2 cases, what we did was we found the perfect square that's closest to 97 and less. In this case, it would have been 81. But notice that difference between 97 and 81 is pretty big. It's 16. So what we want to do is see if there's a number, a perfect square, that's bigger than 97, that's closer than 81, and in this case, it happens to be 100. However, when we use a number that's bigger than the number that we start with, we need to go ahead and subtract instead of add. So that's the only difference. Again, the rest of the method will be the same. On the top will be the difference between 100 and 97, or 3. And on the bottom, it's going to be 2 times 10. Again, where the 2 is constant, and the 10 is going to be from here. And if you change that 10 minus 3 over 2 times 10 and change it into a decimal, you'll get 9.85. Notice the difference? Again, if we go ahead and round the 9.8488 to 2 decimal places, it's 9.85. And using the method, we got 9.85. As you can see, this method works whether the number is small or large. Thank you for watching my video, and don't forget to hit that like button and subscribe.